sort 5-element array. In this part, we will work on a very challenging problem, sorting 5-element array. All right. So to do this one, if we still use the way that we did sorting 4-element array, that won't work. So that is the insertion step, insertion idea with that, binary search in type insertion. So that idea won't work. So the reason is very simple. The reason is we waste some information if we do in that way. So we have to, use some very smart way to solve this problem. Yeah. All right. So before we work on that 5-element sorting problem, first, let us look at how many comparisons do we need if we can find the best solution. The best solution. Yeah. I just used the same formula I talked about a little bit in the previous video. So this is the lower bound for sorting an n-element array, the formula. Oh, sorry. Last time I used the natural log. It should be the log. I used the log base 2, not natural log. Yeah. Last time I remember I used the natural log. It should be log base 2 number, not natural log. Yeah. LG of n factorial seeding function. Okay. So that's the, general lower bound. So if you can get to this number, you must get the optimal solution. Yeah. So when n equals 5, so let's look at the log base 2, 5 factorial. So that is 5 factorial 120. And we know 2 to the 7th equals 128. And 2 to the 6th equals 64. So this number, because seeding function, it is 7. It is 7. Yeah. So our target, we want to use 7 comparisons to find the solution. Okay. All right. Yeah. So let's work on it. 5-element. Yeah. First part, relatively easy. So we do this kind of comparison. X1, X2. We compare X1 and X2, and we assume X1 is the winner. Okay? Yeah. X1 greater than X2. Yeah. Because we want to make our discussion simpler, so we can make some reasonable assumption. Yeah. Then X3, X4, our second comparison. Yeah. First comparison, second comparison, and we assume X3 is the winner. Yeah. Next comparison, third one, and X1 is the comparison. Okay. So this is our first 3 comparisons. After these 3 comparisons, you can see what do we get. Yeah, the information we get. X1, the largest winner, we mean larger here, winner. Then X3, X4 below, X4, and X2 is here. Yeah. After 3 comparisons, so we get information like this. Okay, all right. Now, the next comparison. Okay, X5 was what should we do? Yeah, here, yeah. We have x5 here. We compare x5 and x3. Our fourth comparison, okay? Our fourth comparison, we compare x5 and x3. There are two cases, x5 greater than x3 or x5 less than x3. Yeah. So two cases. Here, let me consider case 1 here. Case 1. Yeah. Case 1, x5 greater than x3. Yeah. So our diagram becomes this one. Okay? x1, x3, x4, x5 greater than x3, x2 here. Okay, all right. Then, next comparison. So, next comparison, that means comparison number 5. We compare x1 and x5. How about that? x1 and x5. Okay, yeah. Which one is larger? Which one is smaller? Number 5. Yeah. Okay. All right. So also two cases. Two cases. Yeah. The first one. So let's say x5 is larger. All right. Yeah. So x5, x1, x3, x4, okay, x2 here, okay, so the first case, yeah, so here, x1, x5, the fifth comparison. Now you can see, to get the whole array sorted, we just need to put x2 in place, right? Yeah. So then two more comparisons, you will make it. 1, 2, okay? Two more, so number 6, number 7. You can make it, okay? Yeah, so that's one case. All right, another case, x1 greater than x5. x1 greater than x5, x5, x3, x4, and we have x2 here, right? Yeah. In this case, two more comparison. We need to get x2 in place. Number 6. Then after that, one more, either with x5 or x4, number 7. Yeah, also 7 comparisons. We can make it. Okay, all right. That's case 5. That's case 1. Case 2. Yeah, here. Let me look at the case 2. Yeah. So let me do it here. Case 2. Okay, yeah. All right. Case 2, x5 less than x3, right? So it's something like this. x1, x3, x4, x5, x2, right? Yeah. All right, so number 5, how about this? x4 and x5, number 5. Yeah. Then you have two cases, right? Yeah. But two cases actually similar situation, x1, x3, x405, x504, right? Yeah, similar situation, right? And you have x2 here. 2 more comparison, you will make it 2 more. Yeah. All right. Number 6. After that, 1 more. Number 7. You can make it. Yeah. So you can see the whole question more complicated. Yeah. But if you can use the diagram to organize your thinking, yeah, and after you made first three comparisons, okay, yeah, then you have some base information. From there, then when you do next comparison, be careful. So the next comparison, you can see this one, that's the binary way, right? Yeah, you can see x1, x3, x4 ordered array. When we try to insert a new one, we do the binary search way. Here you can see we use the binary search way, that idea a little bit. Yeah, not completely, yeah, because this x2, we do not try to insert x2. We try to insert x5 first. After we get x5 in that 4-element array sorted, then we insert x2 as the last element to be in place. Yeah. Yeah. All right. This question is pretty complicated, very complicated. Yeah. I hope you can understand all the steps. Yeah. And if you completely understand the main idea, you can repeat it by yourself. Yeah. All right, so let me finish this last video, E.3, right here. Yeah.